children. It is I, Mr. E. Today we're going to start a new unit, Intro to Quadratics. Intro to Graphing. That's what we're going to do. So let's get right to it. You've already seen Quadratics. They're of this form right here, ax plus bx plus c. Where a, b, and c are real numbers, and we've been factoring these, with the box or splitting the middle, so we've already seen these. But now we're going to graph it, and the graphs look different. This is the graph of a quadratic right here. It's called a parabola. And as you can see, there's quite a few things that we can here, this is so if you remember the most basic function for a line was just y equals x. So if I were to put that on this is called the parent function. This is the linear parent function because that's a line. And remember, if for every input, if x is 1, then y is 1. That's there. If x is 2, then y is 2. If x is 3, then y is 3. And that was this line. This is the simplest line we can have. That's called the linear parent function. Well, similarly, here's the simplest quadratic function we can have, which y is x squared. So if x is minus 2, then the output is 4, because minus 2 squared is 4. And if x is minus 1, then the y is 1, and so on and so forth. And that gives us a parabola. Put an x in, just like before. But notice that you've got two sides here. So let's go on through here and explore a little more of it. So here's the most basic one. This is the parabola of y equals x squared. And the parabola, this is a graph that represents a quadratic function. It's a U-shaped curve. The vertex, first thing, the vertex at which a parabola changes direction. This is the vertex right there. That's also usually the highest or the lowest point of the graph. We'll see that. The axis of symmetry, that's a vertical line that divides a parabola into two symmetrical halves. So that's what this red line is right here. That's what this red line is here. This is the axis of symmetry. Now, notice it says it's a vertical line. So that means we're going to write it as an equation of a line. And since it's vertical, it's going to start with x equals. And this would be x equals 0 is what that axis of symmetry means. Okay, so the roots and the zeros and the x-intercepts, this is where the graph hits the x-axis, and this is usually what we're looking for. We're usually looking for, like right here, it hits right there at the vertex. That's usually what we even call the solution sometimes, so that's usually what we're looking for, is what x equals. So there's, and it has several names for roots, zeros, x-intercepts, sometimes solutions. Or you might even think of it as the answer, but not a great idea, although it's usually what we're looking for in this class. Anyway, we've got the minimum. That's where the vertex is the low point of the graph. So for this graph, the vertex is the lowest point. So this is a minimum. A maximum is where the vertex is the high point of the graph. So like over here, this one right here, that would be a maximum because it's the highest point. The domain. Now remember this, the domain is the x values. So let's look at one of these. Where are all the x values? Well, a parabola goes forever in each direction here. It goes forever up, but also to the right. And this side goes forever up, but also to the left. So what we care about for the domain is that it goes forever to the left and the right. So that means that the domain for any parabola that you see in this class is always going to be all real numbers. So that's very easy. So when it asks you for pieces like this, vertex, axis of symmetry, min-max, domain, range, domain, always going to be all real numbers. And that's simple. Okay, last bit, the range. Okay, so the range is the y values. Let's change colors. Next step is the y values. And these are going to be expressed a little bit differently. Now, this, they go forever up here, but it does have a low point. So that's what helps us find out the range. So the low point here is -9. And all the other values are above it, aren't they? So the range, we're going to say y is less than or equal to, y is greater than or equal to -9, because all the values of y are above -9. So everything's bigger than -9. And -9 in this case is the lowest point, so that's what that range is going to be. So let's continue with this graph here, and let's fill in the rest. Minimum or maximum? Well, that's the lowest point, so that's a minimum. The axis of symmetry, let's see, that goes right here. You can just trace a straight horizontal, vertical line through the vertex. That's at 1, so the axis of symmetry is x equals 1. And the vertex, well, that was at 9, and 1, so that's x, y is 1. Let's look at this next one. This one is similar. It's going up. So let's find the vertex. The vertex is right there at approximately 0. Axis of symmetry, that goes right down the y-axis. So that is x equals 0. And this is another minimum because that's the lowest point. The domain, well, that's easy. All real numbers. And the range, well, let's see. This is similar to the other one. Here's the vertex, and everything is above it. So that's at -4. Vertex is -4. And you can use that to find the y. It's always going to be that. It's always going to be related to that. So if the vertex is 0, -4, and your graph is going up, and that means that y is greater than that Okay, here's a different one. This one's pointing down. So let's take a look at this one. The vertex, that is at, let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's at 4, 9. That's the vertex. Axis of symmetry, that goes right down here at -4. Oh, and it's a -4, 9. Sides here at this point. Okay, so that axis of symmetry is at x equals -4. That is a maximum, isn't it? Because that's the highest point of the graph. So that means, well, the domain is the same, but that means the range is now less than or equal to 9. So there's a little introduction to graphing quadratics, parabola there, and we'll explore that a little bit more as we go through the unit. So that's it for now. See you later.